The compass is a very handy tool to use when you're trying to not get lost in the outdoors. Compasses come in various types. The two that I have here are very common. This one is known as the Ranger style compass, and it has a mirror, which we'll get into why it has that. And this is more of an orienteering compass. It's much more simple and cheaper as a result. Both will work for your purposes. Each comes with a slightly unique set of how to use them instructions. Okay, so these two compasses have lots of similar parts. They both have a base plate, which is the plastic on the bottom here, this see-through plastic. The sides of the base plate are parallel, the left and the right side. And they will also have a few bits of information like rulers, maybe something for showing distance on various maps on the base plate itself. Also, both compasses have what we call a bezel ring, and the bezel ring is turnable, so it actually turns in relation to the base plate. And you'll notice that on the bezel there are the cardinal points, so north, east, south, west, and then northwest, southwest, northeast, and southeast, as well as on the outside a series of degrees, starting at 0 at north and going all the way around 180 at south and back to 360 at north. This compass is the same thing. We have north here, south here, west and east, and then the series of degrees all the way around to 360 at north. Both of these compasses have what we call a direction of travel arrow. So on this compass, the direction of travel arrow is this big arrow here going out the end of the base plate towards the square end of the base plate. On a Ranger style compass with a mirror, the mirror itself is the direction of travel arrow. So if you were to flatten this out, and you can see these little hash marks here, this is the direction of travel arrow. When the mirror is bent over to allow for you to see the top of the compass when the compass is flat, there's a little notch here, which is the direction of travel arrow on this compass. Also common to both is this floating needle on the inside, and this is what we call the north needle. The north needle is red, and it has a balanced side on the other side, which is either black on this one or white. But the red side always points to north, and in this case, it would be magnetic north that it points to. You can also see that it's anything that's slightly magnetized will actually affect the north needle. So a magnet or a cell phone will actually change where it points or deflect that needle. Inside of the bezel ring, you'll also see a small red arrow in here, which is known as the orienting arrow. And in this one here, there's this outline of red arrow, which is known as the orienting arrow on this one. Also inside the housing is these parallel lines, and in this case they're red, and in this case they're black. Those are known as orienting lines, which allow you to take this compass and have it work on a map. And we'll get to that later on. Something that sets these two compasses apart is the fact that the Ranger style compass allows you to set declination, or the difference in angle between magnetic north and grid north, directly into your compass based on the location that you are currently at on the globe, whereas this one doesn't allow you to do that, and you have to manually think about that every time you use the compass. To change declination, you're going to use this small little metal screwdriver, in fact, and it's going to be used on the back in this little brass screw here, and you're going to turn the screw, and it's going to move this black hash mark towards the west or towards the east on this dial here. You find out your declination for the current area that you're going to by going online and putting in the location, which will then tell you what the declination is in that area. Another big difference between these two compasses is the fact the Ranger's compass has a mirror. The mirror can be used for all sorts of things: signaling aircraft, brushing your teeth, shaving, but it's also used most importantly for making your field bearings more accurate, because you can actually look down through this, this hash mark here, or this gun sight, to make sure that you're looking directly at the landmark that you are capturing in a bearing.